case study of and my reflections on many years of collaborative research investigating the sort of the opportunity and challenges of AI-enabled speech interactions with a particular focus on supporting diverse, resource-constrained, and very much underheard communities. And critically, you can see in this case study the application of the human-centered methods to machine learning that Matt, Simon, and Jen were introducing yesterday. So yeah, no, I'm very excited to be here because this is a bit of a homecoming for me. I studied at the University of Cape Town, and my thinking is very much shaped by the ICT4D lab, where I did my honors, master's, and doctoral degrees. So I came to Cape Town in 2008, and that was a particularly exciting point in time because there was a revolutionary technology that was altering the very basis of computing. And I'm talking, of course, of the mobile phone. And yeah, what was exciting is that a digital technology was finding a foothold in places that often didn't have grid electricity. So at the ICT4D lab, we researched and practiced methods of creating and creating and sharing content easy for people who had only just obtained access to a mobile phone. So after graduating, I joined Swansea University, and I now work at the Computational Foundry. And yeah, my desk is right next to the research crucible seen here. And I think I'm even in the center, the blurry man in that picture. And yeah, so foundry and crucible, those are of course words we commonly use in metallurgy. And this language emphasizes that when you bring together different things, in our case, I'll use it as a metaphor, sort of disciplines, communities, and technology, and then apply heat and oxygen, new and very useful things emerge. So just like when I came to Cape Town in 2008, I think we're again sort of living through a particularly exciting moment in time where the basis of technology is sort of changing and shifting again. I'm talking, of course, of AI and machine learning. So in this talk, I'll be going over how we can forge new materials and forms of expression and digital participation by bringing together, disciplines, perspectives, communities, and technology. Oh, yeah, I'll keep that away. Okay, great, thanks. So I want to begin the story of this research in Dharavi. So both Simon and Matt mentioned Dharavi yesterday, so I'll just give a really quick rehash. Dharavi is one of the most densely populated areas of the world. It has between 700 and 1 million residents, and there are quite thriving formal and informal industries situated in Dharavi. So it was sort of a migrant area, so people speak Marathi, Tamil, Urdu. So those are sort of more common vernacular languages spoken in sort of, slightly different enclaves or corners of Dharavi. And then Hindi is used as a vehicular language and is sort of understood by most. We have a vernacular language is sort of the language that you might sort of speak with your gran. So it's sort of used for participation in local life worlds, whereas a vehicular language is sort of the language typically used for sort of education and commerce. So these aren't sort of hard and fast rules, but sort of as a general heuristic, that's how you can differentiate the two. So in Dharavi, again, to sort of rehash a bit from what Simon and Jen covered yesterday, we conducted design workshops to imagine and experiment with new technological possibilities for the future. And participants, in thinking about technology, identified some challenges or barriers to their participation. And in particular, that was around inputting text in their mother tongues. So in Dharavi, this might be Marathi or Hindi or Urdu. So they identified speech interaction as a possible way of breaking down these barriers. So Simon yesterday covered how we rapidly prototyped one of the ideas using a Wizard of Oz approach. So there was a smartphone and Bluetooth speaker embedded into that box, connected to by phone call to a person who was then on the fly answering questions that people posed to the box. So that sort of early stage research sort of prized an opening, and a lot of the research to date has been sort of following where that leads. So given the success of that early exploratory work, we sort of knew that we're onto something here. There were numerous intermittent prototypes, but these are the ones that were part of the larger scale deployment. So that was a machine-powered prototype that ran basically the Hindi language version of Google Assistant. They had just released it when we did this work in 2018, I think. Google Assistant, you press the button, you ask a question, what's the weather, and it'll give you the response. And then we also had a human-powered version, sort of building on the success of the Wizard of Oz study that we conducted earlier, and our hunch that Google Assistant wouldn't be able to answer the types of questions that residents had there. We also had a human-powered smart speaker. So it's called, a human-powered with delayed response. So the interaction there is you go up, you press the button, just with the Google Assistant version, you ask your question, but then instead of getting a response straight away, you get a 4-digit code that you're instructed to remember. So it might be 1, 2, 3, 4, and then instructions to return after about 10 minutes. And so in the meantime, that question got forwarded to a crowd of human answerers. They would try to find an answer to that question within 10 minutes and then record their response. So then if the user comes back, keys in 1, 2, 3, 4, they would hear the response to the question. So to give you sort of a high-level overview of the approach, so we deployed that system for 40 days, and they were very popular. So 12,000 questions were recorded, I have sort of references everywhere in the slides, and I will make sure to share them where you can look at the more detailed results. But generally, people were satisfied with the speed of the Google Assistant version. Dharavi it's just a sort of hustle and bustle, so nothing's better than instant, so people really liked that. But they also appreciated the quality of the human-powered answers, and almost exactly inversely, they were not satisfied with the quality of the Google Assistant answers and were not satisfied with the speed. 10 minutes is a long time in Dharavi. So in response to that, we developed a third prototype, or third system a year later that combined the two. So it had the physical design of this box here. You press the button, you ask a question, and then Google Assistant would try to answer the question. And then if you were not satisfied with the answer, you then had the option to forward it to the crowd of human answerers. And I think what's interesting here is sort of establishing consent at the point of interaction. So there's been a lot of investigative reporting and a lot of concern expressed about smart speakers and voice assistants listening into conversations. So what we did here is we made it an explicit option for users to say, this question I want to forward to a human. It's okay if a human listens into this. And in 71% of the cases, they did this if they weren't satisfied with the answer that the Google Assistant provided. So yeah, here are some examples of the questions that people asked. Who is playing today? I think that's a great one because it sort of shows the sort of indexical nature of speech. And that is exactly the type of question that sort of exposes gaps in what a AI system could do at the time. And for the person, human workers answering questions, that was no problem because they could sort of draw on their shared experiences and context and answer the question. In this case, it was a cricket match that was happening. There were also elections happening when the deployment took place in 2019. So a lot of questions about that. When is the election? Who is the corporator? And what documents might I need for a identity card? So again, the crowd of humans were able to respond when Google Assistant failed. But what was also interesting was when we interviewed the crowd of human workers, they suggested automation as well. So they enjoyed sort of finding the sort of new answers, but there were a lot of repetitive questions about the election or about some other topic. And they wanted ways that, maybe they could sort of inform the model of the instant responses. And so that their task is then to, pick up the slack when Google Assistant fell short, but could also then improve the system. So that was sort of an interesting model, and that was all sort of established with clear user expectations and consent. But we're here in South Africa, and so what about here? There is no, Google Assistant only supports English. There is a ASR engine, Google Cloud Speech to Text, that supports Zulu, Afrikaans, and English. I think it's really great that Zulu is supported, but I think it sort of also raises a sort of political question of why Afrikaans and English, which are both sort of Germanic languages, and not Xhosa. So in post-apartheid and post-colonial South Africa, these types of questions rarely have a neutral answer. So we wanted to address this gap in collaboration with some NLP researchers at the University of Edinburgh and in partnership with community members from Langa. So again, to remind you, Matt and Simon talked about it yesterday. Langa is, not too far, a quick drive along the N2 from here. One of the oldest townships in Cape Town and is now classified as a previously disadvantaged area. It has about 50,000 residents, so much smaller than Dharavi, and a lot less sort of economic opportunity there. And residents are largely first language Xhosa speakers. And we drew on long-standing links we have with community members there. So we wanted to develop an ASR system, so we looked at what are the state-of-the-art approaches. So Facebook's really clever WAV to VEC approach stood out and was creating a lot of buzz and excitement. But one of the problems for, in our case, is that it requires absolutely huge data sets, 53,000 hours. So that's about 6 years of speech data, although most of that is unsupervised. But I think this raises some sort of very critical questions of where does that data come from? And Kate Crawford's book, The Atlas of AI, has been particularly illuminating here. So she thinks about AI as an industry that sort of extracts and abstracts data away from the material conditions of where it was created. And she critiques the approaches that language data is somehow interchangeable, that it's sort of any bit of text is just that text that a a love poem is the same as a legal argument because they both use words. And it also makes the assumption that that language data exists in the first place. So there have been numerous studies that people from Lange are really poorly represented in online spaces, and especially online spaces that are sort of indexed. So a lot of chat, whether sort of back in the day on Mixit and nowadays on WhatsApp, but there's very few text data resources available, which is why Xhosa is classified also as a low resource language in the jargon of NLP research. And another problem is that these state-of-the-art approaches are kind of being placed out of reach of sort of mere mortals. So that only those really big entities, so your Facebooks, your Googles, your Microsofts, are able to actually afford the computational resources to develop a language model. And then also, nowadays it's hard to look past the the environmental costs as well, both in terms of sort of the electricity and climate impacts, and then the rare earth minerals required for all that CPU and GPU power. Critical alternatives in Kate Crawford's view are clearly necessary. And that process often starts and revolves around data. So what do we talk about when we talk about data? So I like sort of go back to the definitions and the history. So the word data is derived from the Latin verb dare, which means to give. And giving, so a datum is a thing given, rather than a thing taken or scraped or extracted or mined. And then, so when something is given, it's also interesting to look at some of the anthropological and social and cultural orientations to that, age-old human practice. So Massa and Maus has written a seminal essay. It's a quite quick, maybe a 1 hour read, that book, but is really, really profound and illuminating because he lays out in such sort of eloquent style the sort of the norms and expectations of gifting that, when you give something, then oftentimes you sort of expect something in return, or let's sort of turn that on the head. Whenever you receive something, you often feel obligated to return something, some in-kind favor. And it's a form of sort of a total social system. So you know how with like NP hard problems, if you face a new problem and you can prove that it is sort of equivalent to some known NP hard problem, then you've sort of proven that by association. So a lot of social practices can be explained through sort of the norms and association of gifting practices. So you're all here gifting me with your attention, and I'm reciprocating by having prepared and thought a lot about this talk. So that's sort of one way of sort of thinking about that. And I think in the world of machine learning and of data-driven systems, there's a similar reciprocal partnership between, designers and users, researchers and communities. They are reciprocally interdependent. But this contrasts a lot with sort of the critique that Kate Crawford made, where data is something that can be taken and abstracted, and there often is very little, expectation. You don't even know who it came from. A lot of language data actually happens to be Enron emails from that sort of corruption case from many, many years ago because they were disclosed openly. So zoop, they get vacuumed up into language models, but they're not really representative to how, regular people speak. So a core question for our team was, how do we retain some of that original meaning of the word data moving forward? And how can we sort of use that orientation to seed some spoken language interactions, specifically for minoritized languages. So what we did, and this work was largely done during the COVID-19 pandemic, so we had to convene some design workshops in quite unfamiliar remote forms. So that involved us sitting around a conference table in Swansea and then connecting to a market researcher in Lange and asking participants to use WhatsApp voice messages to sort of, we use that to engage them. What might they use speech interaction for? So we paired participants into, so 2 participants plus the researchers. We created a WhatsApp group for each of them, so then total of 6 groups. And we asked them to do some activities. So create some voice reminders. So send a voice note to the group with something that they wanted to remember to do, because we thought maybe it would be useful to create a reminder system, or you could sort of query for media content. So we asked them to share a video and then also speak the sort of search query that might surface that video. So we thought that might sort of surface some ideas for interactions. But what ended up happening is that most participants, once they completed the task, ended up chatting in the group. And that, again, at the start of the workshop and at the beginning of every activity, we reminded people that everything you share in this group has a researcher in it and is with the purpose for analysis and for shaping our thinking, and then dissemination as well. So what the participants did was just end up chatting in their groups after completing the task, and we benefited from the what was called the unplatformed approach. The link to the paper is here. So what unplatformed means is that you try and meet the users or the benefactors of your systems on the platforms that they're already using. So to many of the residents in Lange, WhatsApp represents a very familiar and authentic form of expression. So rather than sort of rolling out our own technology, which may have sort of yielded a more accurate data set because we could have captured more metadata or something like that, or could control what audio codec was used. With WhatsApp, we had the advantage that people already had it installed on their phones. And again, the messages then yielded a very rich data set. But the transcription task also became more error-prone, which is what recent research has called sort of a data cascade, where sort of a problem with the data sort of manifests sort of a bit later on in the process. Because remember, at the time, we thought this was all sort of voice reminders and media queries. So to give you an example of a voice message, is this one. I'm not going to read it out, but I've highlighted in upright text all the words that were in Isignosa. In English, is bold. And then, there's one Afrikaans phrase, kokia, which is in italics. But what I find so interesting here, and which I think you should kind of really celebrate, is sort of the creativity and innovation of language use. So linguists refer to the process as code switching between different languages. And residents in Lange call that just mixing. And that also happens at a word, sort of at a sentence level, but then also sometimes at a word level. So e-clock tower and e-waterfront are good examples of that. So that sort of mixes a noun prefix from one language with then the noun from another language. So this presents then a lot of challenges for ASR models, because how do you model code switching at a word or a subword level? And would sort of some errors be okay there for participants giving that challenging context? And then with regard to the voice messaging practices, what was interesting and underreported in the research literature is that participants reported that they used voice messages every single day. Matt, Simon, and Jen were talking about sort of that designed in California mindset that sort of influences a lot of technology design. So there was also a study about voice messaging practices done in the US, and there it was reported that, you might record a happy birthday song for someone. Maybe if you had a newborn baby, you would record voice messages, but generally, the perception was that you were being sort of a little bit lazy by creating a voice message rather than typing it out. Or maybe we can do sort of a quick poll here. Who has sent a voice message this week? Sent or received? Put your hand up. So, quite a few. Doing sort of a similar poll at a different conference, I think only 1 or 2 hands went up because that practice seems to be more rooted here or for people who speak more languages. So in participants' views, voice messaging was seen as very convenient, so there was no spelling errors, and it made sure that everyone could understand you no matter sort of what their textual or media literacy levels are. So it was seen as a very sort of positive and equalizing practice, in stark contrast to how voice messaging is seen in the US, where it's seen as sort of negative and lazy. But it can be kind of tricky to keep up with sort of the amount of voice messages in larger groups. So to give you an example of that, imagine that your chat history looked like this. So imagine the conference organizers had sent you a series of voice messages about the program, the technical content, the Wi-Fi password, when to have lunch. You would have a hard time. You could listen to them. Hopefully you would remember everything, but you'd have a hard time sort of finding older content. What is the Wi-Fi? Which voice message might contain the Wi-Fi password? So this is sort of a challenge that a lot of participants faced. So they go through their WhatsApp chat logs and they scroll, and try and find that old voice message that contained the directions to a friend's house. And it was generally seen as not worth the effort if the message is older than 3 months. So in yesterday's talk, Simon and Jen mentioned that beautiful necklace that people had imagined that they could store their personal data on, sort of keeping it very close to their hearts. So a lot of these sort of voice messages and text message media content, they are also a form of gift that the sender has sort of given to them. So they want to be able to also keep and re-listen to that. But it was seen, again, as not worth the effort because, it's just sort of buried in noise. So what we did was built a prototype that surfaced ASR capabilities here. So again, plugging into, I guess, the Android share interaction. So you long press on a voice recording, you click share at the top, then we built an app called Voice Notes. So you tap on that and it uploads it to one of our servers where it is transcribed using the ASR recognizer that the Edinburgh team had developed using the scarce language resources that were available for Isicosa, which in that case was read speech. So again, our paper has all the sort of nitty-gritty details of the ASR system. But to get sort of back to the users, the ASR system wasn't great, especially given that it was sort of faced with these types of challenges. But it did perform, the errors that it made are somewhat unsurprising. So participants reported that it struggled with informal language, it made typos, and it made errors in sort of switching between languages. So would incorrectly transcribe non-English words as English. But they also reported some positive results. So again, yeah, our paper unpacks these in a lot of detail. So they thought it was pretty cool experimenting with some of these more advanced AI capabilities in their mother tongue, and suggested some other systems, such as translating between languages. So this is sort of also a benefit of using prototypes, or sometimes we call them probes, where you sort of put the technology in the hands of people and allow them to experiment with it, like in their own ways, in their own context, using their own speech. And then based off the sort of experience of using that, we're suggesting systems that in the really early workshops, people kind of struggle to come up with, or they struggle to sort of relate of how ASR could have a more sort of concrete impact in their lives. Yeah, they also identified some recordings where the system performed well, or sort of well enough. And what was really interesting was they thought about when it would be useful to be able to transcribe. So we thought that, yeah, being able to sort of have a collection of recording, then up here you can search for them as well, and that would be sort of the primary use case, sort of having that archive, that sort of personal collection of voice recordings that were sort of important and cherished. But what they also suggested was it was a way of sort of peeking at a voice message. So in fact, a few days ago, I was busy organizing with our collaborator in Lange to do some follow-up work, and she had responded with a 40-second voice message, and I was sort of sitting back there. So I'm assuming that also I see a lot of laptops, I see some mobile phones, and I'm guessing that some of you may have written a email, responded to an email, read a text message. So you're able to do that because text affords that possibility. You can glance at it discreetly without sort of interrupting the flow of this presentation. But if you needed to listen to a voice message, you didn't have headphones, yeah, it would be sort of a very awkward interaction. And again, for our participants, they reported, yeah, using public transport. They didn't have mobile phones, or the headphone jack was sort of busted because when they dropped the phone or some dust had gotten in there. So they wanted a way to look at the voice message content without necessarily needing to listen to it. And oftentimes within sort of a social conversation, you can already sort of expect the gist of the back and forth of a conversation. So being able to sort of draw on that sort of shared understanding gave our ASR system a little bit of an advantage in more sort of qualitative evaluations of that than, say, a word error rate or character error rate metric would surface. So again, sort of you have a use case here that I found it tremendously useful when I was sitting in the audience a few days ago. So we returned to Lange early last year to collect more data, because yeah, again, sort of our evaluations here reported that yeah, it was making too many errors, and we needed more and better data. But again, sort of thinking back to Mause's essay about yeah, what gathering data means, we also wanted the community to benefit from that. So we worked closely with the market researcher and to find a topic that would be of sort of interest to the community, that sort of where there's sort of a lot of talk about. And that was sort of stories of experiences of COVID-19. So we again deployed the familiar speech box hardware. This time you press the button, it prompts you to tell about your experience of COVID-19. When after finishing recording, a prompt is then played to ask whether the participant is happy to share that recording with the research team for analysis and for building technologies that you can speak to. They then also had the option to re-record, or if at any point they walked away and didn't consent to sharing, then we would delete the recording without uploading it. And then finally, after sharing the recording, we then gave them the option of inputting their phone so that we could make a incentive payment to them, which we then did manually behind the scenes, but we tried to do that sort of quite quickly to encourage uptake and participation. So we collected 318 stories and then made 318 airtime voucher payments. And what was interesting is that we also sent out a text message asking them to fill out a survey about what languages they speak, what technologies do they use. And we incentivized that with the same payment amount. So you could get another 20 Rand payment if you filled out this survey. And only 10% of participants did that. So showing again how speech and speech in public context was sort of a easy to use and accessible means for gathering community perspectives on the pandemic. So again, communities like those in Langa are often sort of, I think, quite inappropriately referred to as sort of hard to reach because our typical methods of engagement sort of fall short. They're hard to reach because we can't scrape a data set off them and they don't bother filling out surveys. But if you sort of think about them, work with them and engage with communities, you can find ways that of sort of creating that partnership. So again, I think a speech box like that could be also an effective mechanisms for government organizations or NGOs. But again, the speech data that came back is then from sort of an analysis perspective, or if you wanted to do ASR development, only sort of half the equation. You need those transcripts as well. So a further app that we developed that we sort of formed sort of part of a toolkit for doing community engaged ASR development is a transcription app. And this tries to boil down the transcription app in a mobile friendly and accessible way. So it takes sort of, I think on the speech box we recorded up to 2 minutes of audio. And then the software then splits that up into smaller chunks. And all of those chunks overlap by about, I think, 3/4 of a second. So if a word is cut off at the end of one chunk, it'll be picked up at the beginning or the overlapping beginning of the second one. So you sort of go through listening to about 5 seconds of audio and then transcribing what you hear, and then you move on to the next segment, and then until you get to the end. And we asked had recruited 5 transcribers from the community and asked them to, they transcribed in triplicate. So every story got transcribed by, well, either 2 or mostly 3 transcribers. So that allowed us to sort of assess the consistency or variability of the transcript. And what that revealed in a very sort of concrete way is how Xhosa has quite sort of, is a weakly standardized language, which is typical of more vernacular languages. So the written norms and forms of the language haven't really sort of kept abreast with the sort of the vibrancy and innovation of language use in context, particularly around how words are segmented. If you speak very fast, you tend to sort of, like one word sort of bleeds into the next one. So it then became difficult for transcribers to sort of agree on a gold standard transcript. And that's sort of, again, a core assumption of ASR development methodologies, is that there is such a thing as a gold standard transcript. Our community-generated transcription efforts sort of showed that that wasn't the case. We had sort of 3 transcriptions of the same audio file. They were legible to the transcribers themselves and to other people, but they weren't in a form that was sort of amenable to immediate integration into ASR development pipelines. So again, this sort of surfaced sort of the challenges that working with people and working with communities creates for, some sort of really deeply held norms and assumptions that we make. So that became, so the data, not just for ASR development, it's sort of a valuable sort of conceptual tool that you can use to look at, like, is the pipeline that I've sort of created for developing user-facing ML systems, can it actually work on the data that is being generated in the community? So then, so using the data, we were ultimately able to improve the sort of code-switched ASR system from a character error rate from around 50% to 27%. So that was a good and positive result. And that is typically sort of the end of a NLP contribution. So we collected data, we developed the system, and we can show an improvement. Full stop. Thank you to everyone. End of contribution. But what is sort of really important in sort of community engaged research is to, again, going back to Massa and Mouse, and the original meaning of the word data is to reciprocate, to feed back the results of the research, which in our case was an improved ASR system, but also the corpus of collected stories. So we created a slightly more polished speech box, this time mirroring the look of an actual smart speaker, where people could press the button, again, walk up to 5 publicly deployed devices in Lange, press the button, then they're prompted to tell us sort of what aspect of COVID-19 they would be interested to hear more about. So that could be sort of jobs, money, medicine, of loss. And then the transcriber would transcribe their query. And then, using sort of common information retrieval approaches, I think we used Elasticsearch. We would query the corpus of 318 stories, which we had also transcribed using the ASR system. And if there was a match, we would then play back that story on the device. So there were 750 total interactions. Many of those did not generate a transcript. We don't know if that was because, they didn't say anything, or because the recognizer didn't recognize anything. Again, these are public deployments, so oftentimes there are multiple people speaking, or there's music in the background. But again, since we hadn't sort of established sort of consent at that point to collect data, we decided to not include it for analysis, but only for transcription. And then when a transcript was returned, we would play the story, and then, in some cases they rated it as relevant, but oftentimes I think they were just sort of done with the interaction. They listened to the story and walked away. So I think sort of further down in this Sankey plot, the numbers get too low for really to infer any results. So that was then the end of that phase of the project. So again, that emphasis on reciprocity and going back, returning to the communities that you collected data from to feed back the results. And 10 days ago, I was in India working with a Banjara community, which is sort of the next phase of this of the project that I'm working on. And Banjaras are trader or nomads and have settled in different places in India. And what's interesting is they speak a distinct language called Gormati, which doesn't actually have a written form. So there's some sort of attempts to transliterate it using a different alphabet, but that is only done by a small minority of people. And the community I went to is about a 10-hour drive from Mumbai. And what we did in this community was now we had to work under sort of much tighter constraints from the NLP research side because it is an unwritten language where there are no textual resources available. We had to think about a data collection exercise that was sort of more domain constrained. So we did some more ethnographic research, building links to the community over multiple visits spread out over a couple of months. And then we launched into a more focused data collection visit where we took photos or asked community members to take photos of the different crops that they were growing. So we identified sort of two domains. One was sort of around farming and one was around sort of domestic life. And then asked them to create these photo slideshows, which they could then annotate with a voice recording. So we had to sort of do quite a lot of sort of public engagement around what sort of data AI systems need in order to sort of develop a acoustic model of the language and then do some quite simple information retrieval, such as spotting keywords. So one scenario that they came up with is that it could be good to be able to query market prices of the different crops that they grow. And they had a Gomati-speaking person on one of the farm boards in the next largest city. So the idea was that he could create sort of a long recording with the prices, and if you could sort of spot keywords such as millet or wheat or cotton, you could then sort of go to that bit of the recording and say the price. So again, for a so-called zero-resource language, this is sort of about what you can do in terms of developing speech and language technologies, because there is sort of, the challenges are such that, and there are so few language resources available. So that was what we're doing with the sort of younger community members, creating these slideshows. And then for elderly people, we also developed a IVR system, an interactive voice response system. So it's basically a phone number that they could call and then leave a voice message about, sort of what they did in the farms on that day or sort of around the homestead. So again, sort of checking that, like if you do sort of community-centered data collection exercise, making sure that you're getting sort of broad and diverse voices. And then we also asked community members here to include, to make sure to include women in the exercise, whereas sort of initially, I think only a few men had stepped forward. So our ambition is, again, to collect about 30 hours of domain-constrained speech to develop sort of a simple demonstrator application of what speech and language technology can do for a zero-resource language like Gomati. And then again, the hope is, like with the voice messaging scenario I talked about earlier, is that then that unlocks sort of new suggestions for use cases, such as being able to discreetly look at a voice message when you're on a taxi. And then to wrap things up, what I hope to have shown here is that doing sort of community engagement throughout machine learning development cycles minimizes the chance for data cascades. So our training data set for the initial Lange ASR system had used red speech. Then our engagement in the community surfaced that, actually, voice messaging is a perfect use case. There's a lot of speech data being generated by people, and a huge opportunity for community impact. But red speech and conversational speech are two completely different things. So they lack, it's different speeds, different intonation, So we were able to sort of avoid that data cascade of sort of completing the ASR development pipeline just on read speech and not really accounting for how people act in practice. Yeah, I've also talked about sort of some of the assumptions and orthodoxies of these development pipelines, that you have sort of an objective ground truth. Like a voice message has a gold standard transcript. Again, sort of community engaged research showed that that's not always the case. So coming back to what I learned in 2008 when I first joined the University of Cape Town as a student, there sort of learning about the methods of human-computer interaction and of interaction design, we learned sort of approaches to co-create an interface, a scenario, and a use case. So these are sort of tried and tested methods that have shown to work in sort of diverse contexts to ensure that the technologies that you develop meet the needs of people. But I think particularly for this audience, what we have shown is those same methods can also work to co-create a representative data set. That might not be of the scale of WAV to VEC, of 6 years of audio data, but of really, really invaluable testing data that can sort of guide how you tune, how you evaluate models and avoid those sort of quite costly data cascades. And then again, I want to thank all of the community members, the participants, facilitators, transcribers, and translators, without whom we could not have done this research. And then actually I did bring a IVR system with me, which I will plug into a battery bank very soon. It's in my backpack. I'll do that straight away. So if you wanted to test out that system and give us some feedback on our series of talks, you can call this number here. Just give me a couple of minutes. And then these two websites, Reshaping the Future and unmute.tech, have a lot of the toolkits and papers that I've referenced in this talk. That being said, thank you very much for your attention.
Thanks, Thomas. Any questions? Okay, if there are no questions, I'm sure we can. You can also catch Thomas during tea time. And thank you very much. I think this was the third of the Swansea contribution, and so thank you very much for your contribution and also for the rest of the team. We appreciate that.
Okay, thank you so much.